USB Type-A. This is the classic rectangular USB connector that most people recognize instantly. It first appeared in the mid-1990s when USB was created to replace a messy collection of computer ports like serial, parallel, and PS/2 connectors. Type-A plugs into the host device, usually a computer, game console, or charger. For many years, it was the standard port found on desktops, laptops, and power adapters. The design is simple but not reversible, which means it only fits in one direction. Despite being older, it still appears widely on keyboards, flash drives, and charging cables. USB Type-B. This connector has a more square shape with slightly beveled top corners. It was designed mainly for larger peripheral devices, such as printers, scanners, and external hard drives. Instead of connecting directly to computers like Type-A usually does, Type-B is commonly found on the device side of a cable. The goal was to create a sturdy connection that could remain plugged into equipment that rarely moves. While it is not common on modern consumer gadgets anymore, it remains widely used in office printers and certain professional audio gear. Mini USB. Mini USB is a smaller connector that appeared in the early 2000s as portable electronics became more common. Digital cameras, MP3 players, and early GPS devices often used this port because it was compact compared to the larger Type-B connector. The shape is trapezoidal and noticeably smaller than standard USB plugs. For several years, it served as the bridge between computers and small electronics. Over time, however, it was replaced by an even smaller design as mobile devices continued to shrink. Micro USB. Micro USB became the dominant charging and data port for smartphones and portable devices during the 2010s. It is thinner and flatter than mini USB, designed to fit into extremely slim electronics. Many Android phones, wireless headphones, power banks, and Bluetooth speakers used this port for nearly a decade. One key improvement was durability, allowing the connector to handle thousands of insertions. Like older USB ports, it still only fits in one direction, which is why people often tried plugging it in twice before getting it right. USB Type-C. USB Type-C is the modern universal connector that is quickly replacing almost every older USB type. It is small, oval-shaped, and fully reversible, meaning it can be plugged in either direction without thinking about orientation. Introduced in the mid-2010s, it was designed to support faster data transfer, higher power delivery, and even video signals through the same cable. Today, it appears on laptops, smartphones, tablets, gaming devices, and many accessories. Its versatility allows a single cable to charge devices, connect displays, and move large files at high speeds. USB 1.0. This was the first version of the USB standard released in 1996. At the time, computers used many different connectors for peripherals, making setups complicated and inconsistent. USB 1.0 introduced a unified way to connect devices like keyboards and mice using a single port system. The data transfer speed was modest, reaching about 1.5 megabits per second for low-speed devices and up to 12 megabits per second for full speed. While slow by modern standards, it established the foundation that all later USB versions would build on. USB 2.0. USB 2.0 arrived in 2000 and dramatically increased performance compared to the original standard. It raised the maximum transfer speed to 480 megabits per second, which made it practical for flash drives, external storage, and digital cameras. For many years, it became the most common USB standard worldwide. The familiar black plastic insert inside many USB-A ports often indicates USB 2.0. Even today, countless devices still support it because it remains compatible with older hardware. USB 3.0. USB 3.0 represented a major leap in speed and capability when it launched in 2008. It increased maximum data transfer rates to around 5 gigabits per second, making it much better suited for external hard drives and large file transfers. Ports supporting this standard are often marked with blue plastic inside the connector. Another improvement was better power management, allowing devices to draw more energy while also conserving power when idle. Because of its speed boost, USB 3.0 became very popular on laptops and desktop computers. USB 3.1. USB 3.1 refined the previous generation and pushed transfer speeds even higher. The updated version could reach up to 10 gigabits per second, doubling the capability of USB 3.0. Around the same time, the USB Type-C connector began appearing alongside this standard, allowing faster charging and better support for modern devices. USB 3.1 also improved how data flows between devices, helping maintain stable speeds during heavy transfers, such as video editing or large backups. USB 3.2. USB 3.2 expanded on earlier versions by using multiple data lanes to increase performance. In certain configurations, it can reach speeds up to 20 gigabits per second. This standard works especially well with USB-C connectors, which were designed to support these higher data rates. It made USB more competitive with specialized high-speed connections used for professional storage devices and high-resolution media workflows. USB 4. USB 4 is the newest major generation of the USB standard and was designed to unify several high-speed technologies. It supports extremely fast data transfer rates that can reach up to 40 gigabits per second, while also sharing technology with Thunderbolt systems. USB 4 relies exclusively on the USB-C connector, emphasizing a future where one port handles power, displays, storage, and networking all at once. As modern computers and accessories adopt it, USB continues moving toward a single universal connection for nearly everything.